Have you ever seen a metal bend and twist, like rubber almost,
Yeah,
and then snap right back to its original shape?
yeah, it's pretty wild.
It's wild. That's Nitinol, and it's not magic. Well, it kind of feels like magic.
It does.
But it's a material, and it's really changing the game and everything.
Yeah, really.
From like medical devices to
Wow.
space exploration. It's really incredible.
And you know what's really interesting is how Nitinol is helping solve a major challenge
Okay.
in space travel by creating wheels that are durable enough for extraterrestrial terrain.
Wheels. Okay. That's interesting. I know that sending anything into space is a huge undertaking, but why are wheels specifically such a problem?
Well, think about the conditions. Like on Mars, for example,
Mm.
almost no atmosphere.
Oh.
Means that a regular tire, it would just explode like a balloon.
Oh, wow.
Add to that extreme temperatures that
Yeah.
can make materials brittle and crack, and you've got a real engineering puzzle
Yeah, use that problem.
on your hands.
So it's not just the wear and tear, it's the environment itself that's actively working against you.
Exactly.
So what have they tried in the past
Right.
to overcome these issues?
So there have been some clever approaches. The Curiosity rover
Okay.
on Mars uses solid aluminum wheels,
Okay.
which are strong but heavy. And even those are showing damage from the terrain.
Yeah, I've seen pictures. It definitely looks like Curiosity needs a new set of tires.
It really does.
What else have they tried?
Well, the Apollo lunar roving vehicle, they used wheels made of wire mesh,
Okay.
lightweight, but they couldn't carry very heavy loads.
Right.
And they were prone to bending out of shape.
Okay, so each solution had its limitations.
Yeah.
Enter Nitinol, the metal that might just rewrite the book on wheel design.
It might.
So what makes it so special?
Well, Nitinol has this really incredible ability to remember its shape.
Okay.
You can bend it, twist it, you can even stretch it
Yeah.
way beyond what ordinary metals can handle, and it will just spring right back to its original form. And that's called superelasticity.
I gotta admit, that sounds almost too good to be true.
Right.
How did they even discover a metal that acts like that?
Well, the discovery was actually a bit of an accident.
Okay.
Back in 1961, at the Naval Ordnance Laboratory,
Yeah.
a scientist was examining a sample of nickel and titanium alloy.
Okay.
He heated it up, get this,
Okay.
with his pipe lighter.
Wow.
And the metal completely changed shape
What?
right in front of him.
A pipe lighter. That's amazing.
It really is.
It's like something out of a science fiction movie.
I know, it's crazy.
But what's the science behind this shape-shifting ability?
So it all comes down to two key properties:
Okay.
the shape memory effect
Yeah.
and superelasticity, which we just talked about a little bit.
Okay.
So think of the atoms in Nitinol
Right.
like a neatly organized box,
Okay.
right? That's its structure at higher temperatures, and that's called austenite.
Okay, so nice and orderly. What happens when it cools down?
When Nitinol cools, the atoms get kind of messy. Like someone emptied the box
Okay.
and just scattered everything around.
Yeah.
So this less organized structure
Gotcha.
is called martensite.
So heating and cooling the metal is like switching between a tidy box and a messy room,
Exactly.
and this somehow allows it to remember its shape?
Exactly. So imagine you take Nitinol
Okay.
in its organized box state. You bend it into a new shape, and then you cool it down.
Okay.
So that locks it in that messy room configuration. Now, when you heat it up again,
Uh-huh.
those atoms, they want to go back to their neat and tidy arrangement.
Right.
And in doing so, the metal returns to the shape it had
Wow.
before you cooled it down.
That's incredible. So it's like the metal has a built-in memory of its previous form.
It does.
But what about superelasticity? You said that happens even without temperature changes.
Right. Superelasticity is all about how Nitinol responds to stress. So imagine bending a paperclip. You apply force, it bends.
Yeah.
And if you bend it too far, it stays bent.
Right. Right.
But with Nitinol, even if you bend it significantly, it will snap right back
Wow.
to its original shape when you release the pressure.
Okay. I'm really trying to picture this.
Yeah.
Is there a way you could actually demonstrate these properties? I think seeing is believing in this case.
Absolutely. Let's start with the shape memory effect.
Okay.
Take a look at this Nitinol wire.
Got it.
I can bend it while it's cool,
Okay.
and it will stay in that shape.
Yeah. Looks just like a regular wire to me so far.
And watch what happens when I heat it up.
Whoa, it's straightening itself out. That's wild. It's like it's coming to life.
I know, it's pretty neat.
All right. So that's the shape memory. Now, how about the superelasticity?
Okay, so for superelasticity, let's use this Nitinol tube. As I bend it,
Okay.
pay attention to how it feels.
Wait a minute. It's getting warm. and it snaps back into shape as soon as I let go. That's unbelievable. I could actually feel the energy
Right.
involved in that transformation.
Yeah. So those two properties, shape memory and superelasticity,
Yeah.
are what make Nitinol so revolutionary, especially for space applications like those, durable wheels we were talking about.
All right, now I really want to hear how they actually build those wheels.
So they developed this way to weave individual Nitinol springs
What?
together to create a mesh.
Okay.
And it's an incredibly precise process.
Weaving spread. That sounds incredibly complex.
It is. It is.
How do they even do that?
Picture this, all right. Each tire is made up of
Okay.
684 individual Nitinol springs,
Wow.
all meticulously woven together by hand.
684 springs per tire. That's mind-boggling. I can only imagine
I know, it's a lot.
the time and skill that goes into creating just one wheel.
It's really incredible the amount of work that goes into it.
It's a testament to the dedication and precision involved in crafting these wheels. But the process doesn't end there, right?
No.
These wheels have to undergo rigorous testing
Of course.
to ensure they can handle the challenges of space exploration.
Absolutely.
So what kind of tests are we talking about? What do these Nitinol wheels have to endure to prove they're up to the task?
So they put them through a battery of tests that are designed to mimic the harsh conditions they'll face on other planets.
Yeah.
They use a rotating carousel
Okay.
that simulates different terrains from sand to rocks.
So like a giant hamster wheel for space tires.
Basically.
I love it. But they're not just testing on Earth, right?
No, they also test
Yeah.
on simulated lunar and Martian regolith, which is
right, yeah.
that loose rocky material that covers the surface.
Right.
And these tests are crucial for understanding how the wheels will perform in the low gravity environments of the Moon and Mars.
So they're not just testing for strength and durability, but also for how the wheels handle in those unique gravity conditions.
Absolutely. And the results have been incredibly promising.
Okay.
The Nitinol wheels have demonstrated remarkable flexibility and load carrying capacity.
Wow.
Which makes them ideal for navigating the unpredictable terrains of other planets.
This is truly groundbreaking stuff. It sounds like these Nitinol wheels are straight out of science fiction.
It really does.
And they're actually being used in real-world space exploration.
It is.
I'm completely floored by the ingenuity and innovation on display here. But what about applications here on Earth? Yeah. It sounds like Nitinol has the potential to change things here as well.
You're absolutely right. Nitinol's incredible properties have far-reaching implications.
Okay.
Way beyond space exploration. We're talking things like airless tires.
Wait, hold on.
They're cars. Incredibly.
Airless tires for cars.
Yeah.
Tell me more about that. No more flats.
Right. That's a game changer.
Absolutely. Imagine the impact on safety and fuel efficiency.
Yeah.
If we could eliminate flats altogether.
Right.
They've already tested a Nitinol tire.
Oh, wow.
On a Jeep, and the results were incredibly promising, both on and off-road.
Wow, this is blowing my mind. This one material.
I know, it's pretty remarkable.
Seems to have applications in almost every area of our lives.
It really does. It really does.
But before we get too ahead of ourselves, I want to dig a bit deeper into those Earth-based applications and what the future might hold for Nitinol. We'll be right back after a quick break.
Sounds good. It's really remarkable how material discovered through, like a happy accident is now poised to revolutionize so many industries.
It's funny you should mention accidents because I was reading about how they're even using Nitinol in medical implants, like stents.
Yeah.
And they can actually insert them into arteries in like a compressed form.
And then, because of the shape memory, they expand to open up blockages.
Exactly, yeah. It's a perfect example of how Nitinol's unique properties can be harnessed for, life-saving solutions.
Yeah.
And the medical field is just the tip of the iceberg. Researchers are also exploring Nitinol's potential in robotics, actuators, even adaptive architecture that can respond to changes in the environment.
Hold on, shape-shifting buildings. That sounds like something
I know, right?
Straight out of a futuristic movie.
It might sound far-fetched, but imagine buildings that can adjust their shape to optimize energy efficiency or withstand extreme weather conditions.
That's amazing.
The possibilities are incredibly exciting.
Okay, now I'm really starting to see why everyone is so excited about Nitinol.
Right.
It's not just like a cool metal. It has the potential to transform the world as we know it. But with all this talk about how amazing Nitinol is, are there any downsides? Is it too good to be true?
Well, no material is perfect.
Right.
One limitation of Nitinol is that it can be susceptible to fatigue.
Okay.
If it's, repeatedly cycled through its phase transformations. Think of it like bending a paper clip back and forth too many times. Eventually it breaks.
Right.
But, researchers are constantly working to improve Nitinol's durability and fatigue resistance.
So it's not a question of if, but when we'll start seeing these incredible applications become commonplace. I'm particularly interested in those airless tires.
Yeah.
Can you tell me more about how those work
Sure.
and when we might expect to see them on the road?
So airless tires made with Nitinol, they rely on its superelasticity.
Okay.
So instead of being filled with air, they use a network of Nitinol springs.
Okay.
Or a specially designed honeycomb structure.
Gotcha.
To provide support and cushioning.
Okay.
This eliminates the risk of punctures and blowouts.
Right.
While still offering a comfortable ride.
That sounds fantastic, but are they as durable as traditional tires? Can they handle the weight of a car and the wear and tear of driving on different road surfaces?
That's where the ongoing research and development comes in.
Okay.
Early prototypes have shown promising results, demonstrating good load-bearing capacity.
Okay.
And the ability to withstand repeated stress. However, long-term durability testing is still ongoing to ensure they can meet the demands of everyday driving.
So while we might not be seeing Nitinol airless tires on every car just yet,
Right.
it sounds like they're well on their way to becoming a reality. What other exciting developments are on the horizon for Nitinol?
One area that I find particularly fascinating is Nitinol's potential in the field of elasticalorics.
Elasticalorics. That sounds complicated.
It's a mouthful, I know.
Break it down for me.
So essentially, elasticalorics involves using materials that undergo phase changes, like Nitinol, to pump heat. Remember how the Nitinol tube got warm when we bent it? That's heat being released during the phase transformation.
Oh.
And researchers are exploring ways to control this process to create highly efficient and environmentally friendly cooling systems.
Wait, so you're saying we could potentially have refrigerators and air conditioners that use Nitinol instead of traditional refrigerants?
Exactly.
That would be huge for reducing our environmental impact.
It would be massive. Yeah. It's still early days.
Okay.
But the potential is certainly there. Imagine a future where our cooling systems are powered by a material as simple and abundant as Nitinol.
That's an incredible thought. It really highlights how exploring the fundamental properties of materials can lead to such groundbreaking applications.
Absolutely.
And the best part is we're only just scratching the surface
of
what's possible with Nitinol.
Exactly.
Who knows what other incredible applications will emerge as researchers continue to push the boundaries of material science.
It's an exciting time.
It is exciting.
To be working in this field.
One thing that has really struck me throughout this deep dive is the way Nitinol bridges the gap between space exploration and our everyday lives. It's not just about rovers on Mars. It's about creating a more sustainable and efficient future here on Earth.
Yeah, I think that's a really important point.
Yeah.
The advancements we make in space exploration, they often have, like ripple effects that benefit us right here at home. It's a beautiful example of how scientific curiosity and the pursuit of knowledge can lead to unexpected and transformative innovations.
Absolutely. And it's inspiring to see how a material like Nitinol, which was discovered by chance, is now playing such a crucial role in shaping the future of so many different fields. But with all this talk about Nitinol being this magic metal, I have to ask, are we getting a bit carried away?
It's easy to get swept up in the excitement, especially when you see Nitinol in action. But it's crucial to remember that there's real science behind these seemingly magical properties. It's not about breaking the laws of physics. It's about understanding them deeply and harnessing that knowledge to create materials that can do extraordinary things.
That's a great way to put it. It's not magic. It's the power of human ingenuity and scientific exploration. So as we wrap up this deep dive into the world of Nitinol, what's the one key takeaway you want our listener to walk away with? Something that really captures the essence of what makes Nitinol so special?
I would say the biggest takeaway is this: the power of materials science to shape our future. Nitinol is just one example of a material that is pushing the boundaries of what's possible. Imagine what other breakthroughs await us as we continue to explore the vast landscape of materials and unlock their hidden potential.
It's a thrilling time to be alive, that's for sure. And who knows, maybe one day we'll all be driving cars with Nitinol tires or living in shape-shifting buildings that adapt to our needs.
It's an exciting future.
The future is full of possibilities thanks to the wonders of material science. Thanks for joining us.
It's been a pleasure.
On this incredible journey into the world of Nitinol. Until next time, keep exploring, keep questioning.
Absolutely.
And keep that spark of curiosity burning bright.
It really is amazing to think that something as seemingly simple as, the arrangement of atoms can lead to such profound technological advancements.
It's incredible.
Nitinol is a testament to the power of understanding and manipulating the fundamental building blocks of matter.
One thing that has really struck me throughout this this deep dive is the way Nitinol bridges the gap between space exploration and our everyday lives. It's not just about, rovers on Mars. It's about creating a more sustainable and efficient future here on Earth.
That's a really important point. The advancements we make in space exploration, often have these ripple effects, that benefit us right here at home. It's a beautiful example of how scientific curiosity and the pursuit of knowledge can lead to, unexpected and transformative innovations.
Absolutely. And it's inspiring to see how a material like Nitinol, which was, discovered by chance, is now playing such a crucial role in shaping the future of so many different fields. But with all this talk about Nitinol being this magic metal, I have to ask, are we getting a bit carried away?
It's easy to get swept up in the excitement. Especially, when you see Nitinol in action. But it's crucial to remember that there's real science behind these seemingly magical properties. It's not about breaking the laws of physics. It's about understanding them deeply. And harnessing that knowledge to create materials that can do, extraordinary things.
That's a great way to put it. It's not magic, it's the power of human ingenuity and scientific exploration.
Absolutely.
So as we wrap up this deep dive into the world of Nitinol, what's the one key takeaway you want our listener to walk away with? Something that really captures the essence of what makes Nitinol so special.
I would say the biggest takeaway is this: the power of material science to shape our future. Nitinol is just one example of a material that is pushing the boundaries of what's possible. And just imagine what other breakthroughs, await us as we continue to explore this vast landscape of materials and unlock their hidden potential.
It's a thrilling time to be alive, that's for sure. And who knows, maybe one day we'll all be driving cars with Nitinol tires or living in shape-shifting buildings that adapt to our needs. The future is full of possibilities thanks to the wonders of materials science. Thanks for joining us on this incredible journey into the world of Nitinol. Until next time, keep exploring, keep questioning, and keep that spark of curiosity burning bright.